There's a phantom threat looming over North America. Actually, two. Two predicted cataclysms. Two seismic adjustments that experts say will devastate the USA and neighboring regions with much more force than the other great unknown, the big one of the San Andreas Fault. We're talking about the earthquakes that will soon, or at most within a few decades, strike Cascadia, the vast region along the Pacific Ocean spanning Canada, British Columbia and Yukon, and the United States, Washington, Idaho, and Oregon, and near New Madrid, a town in southeastern Missouri. What's that? You hadn't heard about them? Well, we're not surprised. The earthquakes of centuries past affected regions so sparsely populated at the time that they were soon forgotten. Unlike much more celebrated seismic locations, especially by the film industry, they left traces only in hidden chronicles of the time. However, the danger is still very present, and when another quake shakes that territory, it will likely find a community completely unprepared for the emergency. Fortunately, interest and concern among the population for these events, which all scientific studies now confirm as certain, with the only unknown being when, is growing. People want to know more, understand if and how to prepare even on an individual level, learn what the consequences could be in terms of casualties and damage to buildings, and if authorities are already doing something to ensure communities suffer the least possible damage. But what are the similarities between the two seismic zones? And what are the differences? We will try to answer all this in this phenomenal video by Insane Curiosity Channel, where we will first present the characteristics of the two seismic zones and then compare them to find connections and discussion points. Keep watching and be patient, because the road is long. I want to start this video with a brief but significant anecdote. For decades, seismologists had theorized that due to the particular nature of its terrain, Japan could never experience an earthquake stronger than a magnitude 8.4 on the Richter scale. In 2005, however, during a scientific conference, a Japanese geologist named Yasutaka Ikeda argued that in the near future, the country should expect a quake of at least magnitude 9.0, with catastrophic consequences, because according to him, Japan's earthquake prevention policy was based on completely erroneous assumptions. Ikeda's presentation was met with a polite but timid applause, and then quickly forgotten. But on March 11, 2011, a magnitude 9.0 earthquake and the subsequent tsunami killed more than 18,000 people, devastated northeastern Japan, triggered the meltdown of the Fukushima power plant, and caused about $220 billion in damage. All this is just to remind everyone that seismology is still a young science, far from having reliable predictive capabilities. Back to us. Most people in the United States know only one fault by name, the San Andreas Fault, which runs almost the entire length of California and is always said to be on the verge of unleashing the big one. Regardless of what the San Andreas Fault might do, the fact that it is always portrayed as the ultimate Armageddon is quite misleading. Every fault has an upper limit to the power it can unleash, determined by its length and width, and how much the plates involved can slip under each other. For the San Andreas Fault, one of the most extensively studied and best understood in the world, that upper limit is estimated to be a magnitude 8.2 earthquake. A significant quake, but still, since the Richter scale is logarithmic, about 20 times weaker than the event that occurred in Japan in 2011. But for at least 20 years, geologists have been telling us something else, that the real danger for the USA of a much higher level will come from two seismic regions that the media, all busy emphasizing the danger that was about to destroy Los Angeles in Hollywood movies, have paid very little attention to. The first of these regions is just north of San Andreas, where another fault known as the Cascadia Subduction Zone extends for 700 miles off the northwest Pacific coast, from Cape Mendocino in California to Vancouver Island in Canada. Well, this entire region is now believed to be capable of producing magnitude 8 or 9 earthquakes, as devastating as or even more so than those that struck off Indonesia in 2004 and Japan in 2011. The name comes from the Cascadia Range, a chain of volcanic mountains that follow the same path for about 100 miles inland. The subduction zone part refers to the geological phenomena where one tectonic plate slides under, subducts another. Tectonic plates are those slabs of mantle and crust that, in their centuries-long drift, reorganize the continents and oceans of the Earth. Most of the time their movement is slow, harmless, and almost imperceptible. Occasionally, at the boundaries where they meet, it is not at all. The Cascadia subduction zone is where the tectonic plates called Juan de Fuca and Gorda are colliding with the North American plate and sliding underneath it. The plates move very slowly but continuously towards each other, but at the moment they are locked in the areas where they are in contact. Eventually, the moment will come when the energy accumulated in the collision will exceed that generated by friction, and what will probably be defined as the greatest natural disaster in the history of North America will occur. Terrifying, but how can we be sure of all this? And why is there so little talk about this future catastrophe? Well, there are many reasons, ranging from the media influence of numerous Hollywood versions of the ultimate cataclysm, the one that destroys the iconic city of Los Angeles, to the cultural isolation of wild regions like Oregon and the Canadian border. Until about 40 years ago, the existence of the underwater fault was not even known. The last major earthquake in that area had occurred several hundred years earlier, when the Pacific coast had not yet been colonized by Europeans. Those lands were occupied by Native Americans, who, not having used writing, left no written account of that earthquake. Without traces and clear evidence of a previous cataclysm, and after all, the wild nature does not take long to heal its wounds, the settlers saw the value of that area, fertile, temperate, and seemingly benign, and took it over without realizing its danger. A century and a half passed before anyone sensed that the northeastern Pacific was not a quiet place, but merely a place going through a long period of calm. And it took another 50 years to discover and interpret the seismic history of the region. The first clue came from geography. Almost all of the world's most powerful earthquakes occur in the Ring of Fire, the volcanically and seismically unstable belt of the Pacific that runs from New Zealand through Indonesia and Japan, across the ocean to Alaska, and along the western coast of the Americas to Chile. Let's recall together the mournful chain of the last 60 years. Japan, 2011, magnitude 9.0. Indonesia, 2004, magnitude 9.1. Alaska, 1964, magnitude 9.2. Chile, 1960, magnitude 9.5. Only in the late 1960s, with the advent of plate tectonics theory, did geologists manage to explain this pattern. The Ring of Fire, it was discovered, is actually a ring of subduction zones. Almost all earthquakes in the region are caused by continental plates getting stuck on oceanic plates, like North America's stuck on Juan de Fuca, and then suddenly releasing. And almost all volcanoes form from oceanic plates sliding beneath continental plates, which eventually reach such extreme temperatures and pressures that they melt the rock above them. Apparently, only the northwestern part of the ring showed no signs of seismic activity past or present. Did the Ring of Fire have a gap? The smoking gun for solving the case finally came from Japan, where many documents from that period were discovered, talking about a massive wave that devastated the coast. That wave was clearly a tsunami, but its origin was unknown, so much so that it was referred to in ancient chronicles as the orphan tsunami, meaning without a cause. A few years later, in 1996, it was proven that the tsunami was caused by a magnitude 9.0 earthquake in North America on January 26, 1700. Thanks to this evidence, it was discovered that some Native American tribes had also preserved and passed down the memory of that event. There were indeed stories referring to the shaking of the earth or immense waves coming from the ocean. They were believed to be legends. In reality, they were accounts. And from the Japanese written sources, along with the unwritten ones from Native Americans, we now know with reasonable certainty that at 9 p.m. on January 26, 1700, One of the greatest earthquakes the world had ever witnessed occurred along the western coast of North America. The Cascadia subduction zone disintegrated along its entire length, producing tremendous shocks and enormous tsunamis that swept across the Pacific to Southeast Asia. The recognition of definitive evidence in geological documentation tells us that it was not a unique event, but a disaster that has repeated many times at irregular intervals of hundreds of years. Geological evidence indicates that in the last 10,000 years, at least 41 major earthquakes have occurred in Cascadia. How do we know this? Well, when a strong earthquake occurs in the open sea, the upheaval causes mud and sand to start flowing along the continental margins and into submarine canyons. Coarse sediments called turbidites flow into the abyssal plain. These sediments are distinctly different from the fine particulate that accumulates regularly between major tectonic events. Dating the fine particles through carbon-14 analysis and other methods allows for precise estimation of when the major earthquakes occurred in the last 10,000 years. If you divide 10,000 by 41, you get 241, which is the recurrence interval of Cascadia, the average period of years between one earthquake and another. This period of time is dangerous for two reasons. It is long enough to build an entire civilization on the worst fault line of a continent, and also because it is not long enough to not worry about it. Indeed, 315 years have already passed since the last event of a cycle that has a significantly shorter average recurrence. Of course, recurrence intervals are based on average values, but it is impossible to dispute the magnitude of the problem. The devastation in Japan in 2011 was the result of a discrepancy between what the best science had predicted and what the region was prepared to withstand. The same will apply in the northwestern Pacific, but here the discrepancy is enormous. Recently, geologists have predicted a 37% probability that a magnitude 8.2 event will occur within 50 years, and a 10 to 15% probability that the entire Cascadia subduction zone could collapse with a magnitude 9.2 event in the same time frame. The moment will come when the comprehensive movements of the plates will become impossible to sustain statically, and it will be at that moment that the North American plate will spring back like a spring. After that, we can only imagine what will happen. An earthquake of intensity greater than magnitude 9 will shake the entire Pacific belt, straddling the subsidence zone. Seismic waves with a magnitude between 7 and 8 will reach the coast first. The entire northwestern edge of the continent from California to Canada will sink by at least 2 meters and shift 10 to 30 meters westward. This severe shaking will crumble older buildings, collapse bridges, cause landslides, and trigger the so-called soil liquefaction, a phenomenon where the ground turns from solid to almost liquid, destroying everything above it. Part of this shift will occur underwater, moving a colossal amount of water. The resulting surface wave will rise, forming a large hill, then collapse. One side will rush westward towards Japan. The other will head east, in a liquid wall 1,000 kilometers long that will reach the northwest coast, on average 15 minutes after the earthquake begins, giving people very little time to flee to higher ground. The incoming waves could be 9 to 12 meters high, but some models suggest they could reach up to 30 meters, and in many parts of the coast they could push up to 20 kilometers inland. In the Northeast Pacific, the impact area covers about 360,000 square kilometers, a territory that includes major cities like Seattle, Tacoma, Portland, Eugene, Salem, the capital of Oregon, Olympia, the capital of Washington State, and currently houses about 7 million people. When the next major rupture occurs, that region will suffer the worst natural disaster in North American history, excluding the 2010 Haiti earthquake, which caused the death of over 100,000 people. By comparison, about 3,000 people died in the 1906 San Francisco earthquake. About 2,000 died due to Hurricane Katrina, and nearly 300 in 2012 due to Hurricane Sandy. The grim forecast for the really big one in Cascadia suggests that the earthquake and tsunami will kill about 20,000 people, injure 40,000, and leave at least 2 million displaced for several months. These numbers might seem almost comforting compared to the carnage caused by earthquakes in much more densely populated areas of the world. Well, one might ask, are we at the mercy of these events without being able to do anything to counter them? 40 years ago, when it was realized that sooner or later we would have to deal with the awakening of the Cascadia Fault, we were far from having an idea of what could be done to mitigate the impact of the tsunami. This inaction persisted until 2004, when the tsunami that struck Sumatra convinced local and government authorities in the United States to implement a sophisticated defense system based on real-time satellite detection of any slight sea level variation. For the coasts of the United States and Canada, scientists at alert centers are now generally able to issue the first warning messages within 5 minutes of an earthquake, ensuring, in the case of the Cascadia Fault, a warning time for the population of about 25 minutes before the tsunami arrives. Not much, but let's not forget that we are not talking about just any catastrophic event, but the really big one. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. New Madrid. However, if the information about the last earthquake in Cascadia is quite fragmented, for the second source of deadly danger we want to make you aware of, it is absolutely proven. The hills of western Tennessee are not what most of us imagine when we think of earthquake risks, but we would be mistaken. Far to the east of the more well-known subduction zones of California and the Pacific Northwest lies the New Madrid seismic zone. This area includes parts of Tennessee, Kentucky, Indiana, Missouri, Illinois, Arkansas, and Mississippi, and is the source of the largest historical earthquakes in the United States east of the Rocky Mountains. Experts tell us that a major event along the New Madrid zone today would cause extensive damage to buildings, bridge collapses, disruption of essential service systems, and failures of levees and slopes for hundreds of miles or more. It is a threat that those who live and work in the region simply cannot afford to ignore. But where does such pessimism come from? Well, from the past. We know for certain that in December 1811, an invisible force gripped the central Mississippi Valley and did not let go for weeks. A series of major earthquakes caused the riverbed to rise and fall as if it were a stormy sea. On February 7, 1812, just upstream from New Madrid, Missouri, the land was deformed to the point that the mighty Mississippi began to flow north instead of south. That event was the culmination of a period of terror known as the New Madrid earthquakes. On December 16, 1811, at 2 in the morning, the first earthquake struck what is now the southern tip of Missouri. Residents of both rural and urban areas woke up to furniture bouncing and porcelain plates shattering. Houses were shifting from their foundations. People poured into the streets, trembling from the cold and the tremors. Their homes, once quiet and safe, had suddenly become a danger. In the hours before dawn, the ground continued to shake, though with less intensity. Around 7 o'clock, there was another violent tremor. Then, around 11, there was an even stronger one. The ground opened up in chasms from which mud, water, and coal gushed out. Sulfurous gas emissions from the underground contaminated the air with their foul smell. Eyewitnesses saw thousands of birds flying away from the area as if they had gone mad. When the violence of the tremors ceased, Little Prairie, a town in Missouri, was destroyed. Lesser tremors continued until January 1812. On the morning of January 23rd, around 9 o'clock, another strong earthquake sowed terror. Point Pleasant, already battered, was near the epicenter, and the inhabitants fled. When some returned in February, they realized that not only was the town destroyed, but there was no trace of it left. Due to the January 23rd earthquake, Point Pleasant and the ground it stood on had been hurled into the Mississippi. But it wasn't over yet. The disaster continued to strike the region. On February 7, 1812, before dawn, the restless sleep of the inhabitants of that area was again interrupted by tremendous seismic waves. The epicenter was beneath them. This earthquake, more violent than all the previous ones, was so strong that in Cincinnati, Ohio, 650 kilometers away, it knocked down chimneys. In Boston, Massachusetts, 1,600 kilometers away, the earthquake rang church bells. Much further north in Montreal, Canada, the sound of plates and saucers rattling on tables was heard. A man in Kentucky living 130 kilometers from the epicenter wrote in his diary, "If we don't get out of here, the earth will swallow us alive." The fury of the earthquake, however, was particularly unleashed on the river town of New Madrid. The 1811 tremors had already severely damaged the small town, killing several residents and forcing most of the survivors to leave. The February 7th shock delivered the final blow. When the earthquake struck, the remaining people fled just in time. The elevated bank on which the town stood crumbled and slid into the Mississippi, where the turbulent waters swept away the planks, bricks, and stones of New Madrid. In a short time, no trace of the town remained. The earthquakes created temporary waterfalls on the stretch of river near New Madrid, capsizing dozens of boats. The February 7th shock lifted and sank the ground, forcing the Mississippi's current to flow in the opposite direction. Huge chasms opened under the river, creating whirlpools that swallowed more boats. The earthquakes altered the river's course, flooding towns and plots of land. They also diverted waters, creating Reelfoot Lake in Tennessee, which did not exist before 1812. The earthquake was so powerful that within 3 minutes, seismic waves reached Charleston, Washington, and Boston. The tremor lasted 15 minutes, and needless to say, even the sturdiest brick and stone houses collapsed to their foundations for miles around. St. Louis and Louisville suffered severe damage. Aftershocks pounded the country for days. Out of a population of about 15,000 in the affected area, more than 1,000 people were killed and at least 5,000 were left homeless. Are you thinking that the human losses were not so terrible compared to the recent carnage in Haiti and Turkey? Well, you might change your mind when you reflect on the fact that at that time, the population density was 1 person per square kilometer. In addition to the loss of human lives, there was also structural damage. 5 settlements, a military fort, and countless Indian villages disappeared from the face of the earth. In many places, the ground was gutted and then covered with sand, boils, fissures, and crevices. There were dead trees everywhere. Swamps were lifted and drained, while good pasture and farmland were submerged by new enormous lakes. The still young United States had never experienced a disaster of such magnitude. It is impossible to determine the exact magnitude of these earthquakes, as seismographs did not exist in 1812. Scientists estimate that at least 3 of the New Madrid earthquakes, measured on the Richter scale, would have had a magnitude greater than 8. These are the most intense earthquakes ever observed in the continental United States and among the strongest ever recorded worldwide. Okay, this is a quick account of what happened more than 2 centuries ago. A catastrophe that, due to the very low population density of the affected areas and the slow speed at which news spread at the time, was soon forgotten by everyone, including the central government, which even neglected to bring aid to the survivors. But all this concerns the past. If we want to deal with the present, we must get used to the idea that seismic activity in that area still exists, that it has never stopped, and that in the meantime, the total population of those places has risen to 5 million people. It would be an apocalypse if the 1811-1812 tremors were to repeat today, wouldn't it? And it only takes a simple calculation to understand it. If 2 centuries ago, the percentage of victims relative to the population was 7%, not counting the losses suffered by the natives, which are difficult to compute, with an earthquake of the same power, we should expect at least 300,000 deaths today. A massacre. But is the New Madrid Fault really still active and a high risk for the population? At the beginning of the 20th century, the area began to be the destination of numerous scientific expeditions, with flocks of geologists eager to understand what could have caused such intense earthquakes in a region where there were no surface faults like California's San Andreas. After decades of excavations and studies, it was understood that the seismic activity of New Madrid is not due to the tug-of-war of 2 antagonistic tectonic plates, as usually happens in the vast majority of violent seismic manifestations. The critical zone, in fact, is not on the edge of a plate, but near the center of the North American plate, buried 600 to 900 meters deep by thick river sediments. It should not be surprising if even areas far from plate margins are occasionally hit by earthquakes. Even the largest and most stable plates, where geological movements ended billions of years ago, can sometimes undergo internal deformation, mainly determined by the pressures their edges undergo. Another theoretical reason for the development of intraplate earthquakes could be the birth of a new margin, that is, a new rift zone due to the separation of a plate into two distinct plates, and this seems to be the most likely case for New Madrid. It is estimated that 0.5% of the seismic energy released in the world is attributable to earthquakes that originate far from the edges. The remaining 99.5% is due to the more numerous and stronger ones that occur along the plate margins. In the case of New Madrid, it also happens that the harder, colder, drier, and less fractured crust of central United States can generate tremors over large areas compared to comparable magnitude earthquakes that occur in the West. The geological structure of the New Madrid Fault Zone is indeed made up of layers of sedimentary rock, like limestone, which spreads and amplifies the tremors just like when hitting a bass drum. Due to this chain effect, an earthquake along the New Madrid Fault Zone would travel farther and cause more damage than a similar magnitude earthquake on the West Coast. Today, the New Madrid Fault Zone, which is active, continues to move, holds the highest seismic risk in North America east of the Rocky Mountains. Currently, an average 200 earthquakes occur annually near New Madrid, most of which are too small to be felt. About once a year, a magnitude 3.0 earthquake occurs, and about once every 10 years, a magnitude 5.0 or higher earthquake occurs. As we've already mentioned, earthquakes cannot be predicted, but probabilities can be calculated based on evidence of past seismic activity. Scientists estimate that there is a 10% probability of a magnitude 7.5 or greater earthquake occurring in New Madrid in the next 50 years, and a 25 to 40% probability of a magnitude 6 or 7 earthquake occurring in the same period. All of this, of course, with significant damage and loss of life. One day, perhaps without any warning, an absolutely massive earthquake will strike the New Madrid Fault. When that happens, thousands of Americans will die, tens of thousands of structures will be completely destroyed, and millions of people will be left homeless. This would be a nightmare from which none of us could wake up. So since we don't know when the big event might come, the best thing to do is to prepare, imposing extreme safety measures across the territory. Unfortunately, we know that very little has been done in this regard by the authorities, and this certainly does not leave us feeling reassured. The lesser of two evils. But what are the similarities between the two seismic zones? Not many, besides their shared potential for human and economic devastation of large populations. The differences, however, are more interesting. To begin with, these two seismic zones are of different types. As we have already said, Cascadia is an interplate subduction zone, while New Madrid is an intraplate fault system. Intraplate fault zones are places where plates have fractured and the parts move relative to each other. The resulting earthquakes are called intraplate because they occur far from the edge of a tectonic plate. These types of earthquakes are believed to reach a maximum Richter value of 8. The estimated peak of the New Madrid events was about 8.1, and the 2012 Indian Ocean earthquakes off Aceh were 8.6 and 8.2, and were probably the strongest intraplate earthquakes ever recorded. Another known intraplate fault system in North America is along the St. Lawrence River. The risk of earthquakes in Montreal and surrounding areas is real. Subduction zones like the one in Cascadia, where oceanic plates move under continental plates, are found all around the Ring of Fire or Pacific Rim. Subduction zones cause the most catastrophic earthquakes, usually responsible for all events of magnitude 9.0 and above. Indeed, listing the famous earthquakes of magnitude greater than 9.0 in the last half-century: Sumatra 2004, Japan 2011, Alaska 1964, Chile 1960. they are all related to subduction. Decoding the Richter scores reveals that the worst subduction earthquakes are about 10 times stronger than the worst intraplate earthquakes. In this sense, we must certainly conclude that the worst of the two evils is in Cascadia, especially considering that the movement of the underwater fault could cause not only a destructive earthquake, but also an almost certain tsunami. Subduction earthquakes are indeed the main cause of tsunamis, and the coast from Oregon to British Columbia could be devastated by waves up to 60 meters high, carrying debris, vehicles, buildings, and trees. Based on seismic potential, the Cascadia earthquake seems to be the worst of the two evils, but the crucial point might be another. The new Madrid earthquakes might be less devastating, but they could be the most costly in terms of human losses and infrastructure damage. Experts assure that they would be the most expensive disaster that could hit the United States. The reason lies in the significant difference in population density between the two regions, with 47 million inhabitants in the new Madrid region compared to 15.5 million in the northwestern coastal region. Think about it while you still have time.